Hey guys, this is Mr. Sal. We're going to look at solving exponential equations and logarithmic equations. Thanks for watching. Don't forget to like, comment, and subscribe. Alright, uniqueness of b to the power of x, same basis property, that's all this is. If your bases are the same and they're equal, then just work with the equation with the exponents on that. Of course, you'll want to check your answer just to make sure not only that you did it right, but that it does actually work, because especially when we get into some of the roots which have rational exponents, then it kind of changes things quite a bit, right? Like this, 5 to the power of x equals 125. Well, 125 is 5 to the power of 3. So if I had 5 to the power of x equals 5 to the power of 3, then I can just make this x equals 3, right? It's not that I canceled out the bases, the 5 bases. It's just that since the bases are the same, I just need to compare the exponents on that. And you could check, right? 5 to the power of 3 is 125. That seems to work. 4 to the power of x equals 8. 8 is not 4 to any power. Well, not any rational power. So we would change 4 to 2 to the power of 2. And then we'd make that to the power of x. And 8 is 2 to the power of 3. Right? And what would we do with the powers right here? The 2 and the x would multiply them. So it's really 2x equals 3. And then to solve that, you'd divide both sides by 2. And you'd get x's 3 halves. And of course, you could check that. 4 to the power of 3 halves is 8. Alright, so solve something like this. Again, if we can make the bases the same, and yeah, some of you guys don't need to figure out the same basis because you know what it is, but if we can, then we can compare just the exponents. So 100 would be 10, it's a base 10 to the power of 2. So we got 10 to the power of x equals 10 to the power of 2. So again, it's not that they're canceling out, we're just going to ignore the bases and compare just the exponents. Bam, that one came out pretty quick. And again, you could check that. X is 2, so 10 to the power of 2 is 100, and it checks out. Use the like basis property and exponents to solve this equation. Okay. All right. Now, when we do this, we need to get the base and the exponent kind of by itself, right? We don't want to multiply it by anything or subtracting or adding anything like that, minus 24. So we're going to manipulate this for the base and the exponent part of that, which is just 5 to the power of x. Now be very careful with that because some people assume that the 6 also has a power of x, but it doesn't. And the worst possible thing I could see on a test for this is this right here. Okay. We don't want to see it. We don't want you to do it. Avoid it. It's even out of the order of operations if you think about it, right? So get rid of that garbage. Don't do it that way, please. What we need to do is manipulate this, so we'll add 24 to both sides. So with that 6 times 5 to the power of x stuff, we don't want the 6 multiplied by it, so we're going to divide both sides by 6. Seems like we've seen this before, right? So we can kind of skip the work on that. We know 125 is 5 to the power of 3, so x is 3. And again, you could go back and check that. 5 to the power of 3 is 125 times 6 is 750 minus 24, 726. Bam, done. All right, so solving this, that's not too bad because the bases are already the same right there. Even in a problem like this one, right? Just getting rid of the bases is pretty nice. We get this equation. That's, well, I guess it's kind of linear. It's a one variable equation, right? And it's linear, so it's not like we're looking at factoring necessarily right here, right? So on this one, just very basic. Which side do we want the x's on? Which side do you guys want it on? The right? Because we don't want those negative coefficients, right? So we'll subtract x from both sides. which means that minus 8 is, or the negative 8 is on the wrong side, so we'll have to add 8 to both sides as well. So I got 1 equals 6x now, and we'll divide both sides by 6. So my coefficient of x is 1, x is 1/6. And again, you could go in there and check it. I mean, once you find that the exponents of 10 are the same, then you're in good shape. This one's a little different, but we notice with the bases, one's 1/3 and one's 3. So we just need to make either the 3 a 1/3 or the 1/3 a 3. In general, most people like to make the 1/3 a 3. But we got to go back to exponent rules for that, right? It's really just reciprocating this fraction so that it's a 3. Right, I mean, we could show 3 over 1. It's just not necessary that we do. But if I do that, what do I have to do now? There you go, yep. That's to the power of -1, right? And this was to the power of n minus 1. This equals 3 to the power of 3n minus 10. Now again, going back to exponent rules, we would multiply these two, and you can put parentheses around the n minus 1 if it helps us. So it ends up being 3 to the power of -n plus 1, and this equals 3 to the power of 3n minus 10. Well, now we've accomplished getting the bases to be the same. So we get to ignore those, and we just got -n plus 1 equals 3n minus 10. So usually we would say, well, I want the n's on the right side, so we'll have to add an n to both sides. You can show the one n if you want, right? And that means we'll have to add 10 to both sides. And from here, we'll divide both sides by the coefficient of n, which is 4. So n equals 11/4. Use the like basis property to solve this equation. So this is one of those that you could use the logarithms to solve. Now it did tell us to use like basis specifically to solve this. So that's what we're going to do, even though, again, you could use logarithms. So we got this 1/9, and just real quick, I mean, just like the last problem, I'm going to change this so that my base value is not a fraction, all right? And this equals 81 to the power of n. And I don't know, we have to kind of think about this in terms of base 9, particularly because it's the lower one. And we can change 81 to be a base 9. That would be 9 to the power of 2. Now, it is possible some of you were thinking base 3 for that, and that's okay. The base 3 will give you the exact same answer, all right? But in this case, if we make 81 9 to the power of 2, then we got 9 to the power of 2 to the power of n. And we do have the same bases, so we can compare just the exponents, right? So I've got my 2n, and this equals the exponent for the green 9, -1. And now to solve, we'll divide both sides by 2, and we see n is -1/2. Now again, you could plug that in. 81 to the power of -1/2, and it should be the same thing as 1/9, or 0.1 repeating. Well, bases are the same, so we're just going to write the equation with the exponents. X minus 3 equals 8x plus 2, and to solve this would subtract x from both sides, assuming you're putting the x's on the right, and you'd subtract 2 from both sides. So you got -5 equals 7x. And then to solve, just divide both sides by the coefficient of x, 7. So x equals -5/7. All right, here's another equation. We've got a base 4 and a base 8. And we can't do that directly. We can't make 8 a base 4 directly, or we haven't really learned how to yet. So we need to change the bases into, I don't know, something more workable probably. Specifically, hopefully we know that, right, 4 is 2 times 2, and then 8 is 2 times 2 times 2. So that helps us to understand, hopefully, that we can use a base 2 for both of these. 4 is 2 to the power of 2. Again, I would write the whole thing out just to show the work for this part. So it's 2 to the power of 2, but that's to the power of 2x minus 5. And then the 8 would have been 2 to the power of 3. And this is to the power of 2x plus 5. So this gets us the same base, which is what we want. Let's do the work with the bases first on that. Alright, so we'll multiply the exponents on this. So if I were to look at the 2x minus 5, I'll be distributing the 2 into that parentheses, and the 3 also into that set of parentheses for the 2x plus 5. Well, from this, right, again, if we could get the exponents to be the same, then we'd have the same value either way. So we could ignore the two bases and just solve for the exponents. Well, our higher one, the higher coefficient for x is on the right, so we'll subtract 4x again. Alright, well, we'll just divide both sides by the coefficient of x, 2, and x equals negative 25 halves. Alright, solve this equation round to 4 decimal places. I mean, you could use guess and test on this thing just to see. Right, you could say, well, what if x was 1? Then you got 3 times 1 minus 3. That's 4 to the power of 0. That's not really helpful. You could try to get the exponent to be 2 and 3 and so forth. But we need 4 decimal places on this thing, right? So what we're actually going to end up doing is using logarithms, kind of like we talked about in the first place. So let's change this to a logarithm, right? Alright, so this is going to be a log, and the base is the 4 here. So it's a base 4, and the answer for this is 34, right? Oops, right here. And then the exponent, that's what this will equal, 3x minus 3. Alright, now you can't find that logarithm by using the change of base property, right? I'm going to wait to do that, I guess, just so I can plug it all into my calculator once. Which means that for me, I'm going to start by adding 3 to both sides of this equation. Now, if you did evaluate that log first, that's fine. All right, you just want to make sure you keep the right number of decimal places. I would say at least 5. You just in case your rounding comes back, right? Because right here, now that we have 3x and we just want x, we're going to divide this whole thing by 3. So that will solve for x. And this is something I'm going to plug in my calculator. For the log, do you guys want to use natural logs or common logs? Sorry? 3. So the order of operations, I do need to figure out what the log is as a decimal, right here. I don't know. That seems like it's a little bit easier to evaluate. So let's plug this into the calculator. Now when you get this, you could plug it back into the equation just to check to make sure it works. But you probably won't get exactly 34 because of the rounding. So just keep that in mind. I guess it's lower than the actual, so maybe something like 33.99. Something to that effect.